Today we are going to continue solving equations. The types of equations we are going to solve are multi-step equations and equations with variables on both sides. So our first example is 8x minus 3x minus 10 equals 20. The end goal here is still to get x by itself. We just have to do a few more steps before we solve. So your first step is always to combine like terms. On this specific problem, I would draw your algebra wall, and then I would look at each side separately. So looking on the left, the like term that you have with 8x is 3x. So 8x minus 3x gives us 5x, and then we're going to bring down the minus 10. I can't combine 10 and 5x because they are not like terms. By doing that step, we are now to our two-step equation. We are trying to get x by itself, so your first step is to move whatever's being added or subtracted. The opposite of subtracting 10 is to add 10 to both sides. When you do that, you're left with 5x equals 30. From here, we need to get rid of the 5. So the opposite of multiplying by 5 is to divide by 5. That cancels the 5 on the left, and our final answer is 30 divided by 5, which is 6. This can be checked by plugging it back in. I would always plug it back into the original. So I'm going to plug in 6 for both of my x's. I have 8 times 6 minus 3 times 6 minus 10 equals 20. Well, 8 times 6 is 48. 3 times 6 is 18. So then when I combine this, 48 minus 18, excuse me, gives me 30. And 30 minus 10 is 20. So I know I did it correctly. Your calculator will actually check this for you quite easily as well. So I'm going to show you how to check really quick in your calculator. What you're going to do is you're going to type in your original equation, but instead of using x in the calculator, we're going to plug in 6. So every time you plug in 6 on your calculator, I want you to get in the habit of using parentheses. The parentheses are right next to the 0. So I'm going to type 8 parentheses 6 minus 3 parentheses 6 minus 10 equals 20. You can actually include the equal to sign straight into the calculator. When you hit enter, the calculator will tell you if that is true or false. If you get true, that means you have the right answer. If you get false, that means you made a mistake whenever you were solving. Let's look at our next example. 7x plus 2 parentheses x plus 6 equals 39. This problem is a little bit different because of the parentheses. If you think back to middle school, you should have learned something called the distributive property whenever you have parentheses. Here's a refresher on what to do for distributive property. The 7x is going to be left alone for right now. And then the 2 outside of the parentheses, we are going to distribute to both the x and the 6 in the parentheses. When you distribute, you are multiplying them together. So 2 times x gives me 2x, and 2 times 6 gives me 12. From here, I'm going to combine like terms. So 7x plus 2x is 9x. And now I'm back to my two-step equation. My first step is to move the 12. The opposite of adding 12 is to subtract 12. And then the opposite of multiplying by 9 is to divide by 9. So my final answer is x equals 3. This problem can easily be checked in your calculator as well. If I type this in, I'm going to type in my original equation. But remember, instead of x, we're going to plug in our answer. In this case, our answer is 3. So in the calculator, I have 7 parentheses 3 plus 2. I'm going to have my outside parentheses, and then I'm still going to plug in 3 with parentheses, plus 6, close my parentheses, and then equals 39. The calculator tells me that that is true, so we did it correctly. Go ahead and pause the video and try these two problems. Restart it when you're ready. On number 1, your first step is to combine like terms. 9d minus 2d gives us 7d. Then you're back to your two-step equation. So first I'm going to subtract 4 on both sides. Then I'm going to divide by 7. You should have gotten d equals 4. On number 2, your first step is to deal with parentheses. What you have to be really careful with on number 2 is your signs when you're distributing. If you look at the 2, it has this negative sign right in front. That means that we are distributing a negative 2. The 6x is going to stay put for now. Negative 2 times x is negative 2x. And then be really careful on this step right here. Negative 2 times negative 5 is positive 10. A negative times a negative makes it a positive. From here, I'm going to combine like terms. 6x minus 2x is 4x. Now I'm back to my two-step equation. I'm going to subtract 10 on both sides. Then I'm going to divide by 4. So your final answer for number 2 is x equals 9. Here's another type of multi-step equation. This is one that has fractions on the outside of the parentheses. This is kind of similar to the fractions we dealt with 1 and 2-step equations. Now, technically, you could distribute 3/2 to both 3 and 5. However, that's going to give you 2 fractions that you really don't want to have to deal with. So instead, since 3/2 is outside of the parentheses, I would get rid of it at the very beginning. You can either get rid of it by multiplying by the denominator, or you can get rid of it by multiplying by the reciprocal. I'm going to use the reciprocal method. The reciprocal of 3/2 is 2/3. So I'm going to multiply both sides here by 2/3. When you do that, the 2's and the 3's cancel on the left, and you are left with 3x plus 5. On the right, negative 24 is the same thing as negative 24 over 1. So when you multiply these together, negative 24 times 2 is negative 48. 1 times 3 is 3. And this is going to reduce to negative 16. Now we're back to our two-step equation. So I'm going to subtract 5 on both sides. Be careful with your signs. Negative 16 minus 5 is negative 21. Then from here, I'm going to divide both sides by 3. So x is negative 7. I want to show you how to check this in the calculator, especially since we have a fraction in the original. To get your fraction tool, you can use the toolbox right next to the number 9. I would grab the fraction tool and type in 3/2. Then you have to come out of the fraction and type in your parentheses. And remember, instead of x, we are plugging in our answer, which is negative 7. And then we're going to set it equal to negative 24. So I typed this straight in like the original was, but instead of x, I now have negative 7. When you hit enter, the calculator will tell you that that is true. So we did that correctly. Our next example is very similar, except now our fraction is negative. So what you're going to do if you're using the reciprocal method is you're still going to multiply by the reciprocal. In this case, it's 5/4. But I'm going to actually take the negative with it to get rid of it. So I'm multiplying both sides by negative 5/4. The 5's cancel, the 4's cancel, and the negative sign cancels. So on the left, I am left with 4a minus 1. On the right, if you're having trouble multiplying by a fraction, you have a couple options. You can use your calculator, you can multiply straight across, or you can say 4 goes into 28 7 times, and 7 times negative 5 is negative 35. Now it's time to get a by itself. So my first step is to add 1 on both sides. And when I do that, I get 4a equals negative 34. From here, I'm going to divide by 4. And when I do that, I'm going to get a fraction or decimal. As long as you simplify your fraction, you can leave it in fraction form. So in this case, I'm going to reduce that to negative 17 over 2. Let's check that in the calculator. So to put in a negative fraction, I'm going to put the negative sign first, grab the fraction tool, and then I'm going to put 4 over 5. In the parentheses, I have 4 parentheses, and then since my answer is negative, I'm going to put the negative sign first. Then I'm going to grab the fraction tool again and put 17 over 2, our answer. I'm going to get out of the fraction, close those parentheses, and then I'm going to subtract the 1, close the parentheses again, set it equal to 28. When you hit enter, the calculator will tell you that that is true. Go ahead and pause the video, try these two, and then we'll check. On 32, to start, I would multiply both sides by the reciprocal, which is 7 over 8. The fraction cancels on the right, and we're left with 3w minus 1. On the left, 8 goes into 32 4 times, and 7 times 4 is negative 28. From here, I'm going to get w by itself, so I add 1 to both sides. And then I need to get rid of the 3, so I divide 3 on both sides. Your answer is negative 9. On number 4, same thing. I'm going to multiply by the reciprocal, which is in this case is 5 over 2. 2 goes into negative 14 7 times, so 5 times negative 7 is negative 35. On the right, I'm left with 9 minus 2b. From here, I need to get b by itself, so first I need to move the 9 over. Be careful, 9 is positive here, so I'm going to subtract 9 on both sides. When you do that, negative 35 minus 9 is negative 44. Don't forget to bring down the negative in front of the 2. When you do that, be careful with your signs. I divide by negative 2, and b is positive 22. We're now going to move on to equations with variables on both sides. When you have variables on both sides, a lot of people find it helpful to draw the algebra wall in. If your variables are on opposite sides of the algebra wall or opposite sides of the equal to sign, you have to do opposite operations to get them combined. Be careful with the difference between this and with the combining like terms we did before. Before, our like terms were on the same side, so we did not do opposite. We did exactly what it said. Now, since I'm trying to move something over to the other side, you have to do opposite. My word of advice is to move the term that is smaller. This will help avoid negatives. In this case, I have negative 3m on the left, and I have 5m on the right. Since negative 3 is smaller, I'm going to move that one. The opposite of subtracting 3m is to add 3m to both sides. When you do this, 3m cancels on the left, and I'm left with 24. On the right, 5m plus 3m is 8m. Now we're back to our one-step equation. To get m by itself, I need to move the 8 to the other side. The opposite of multiplying by 8 is to divide by 8. So my final answer is m equals 3. The best part about this kind is, again, you can just check this in your calculator. I'm going to type in the original equation, but instead of putting m's, I'm going to plug in 3 as my answer. So I have 24 minus 3 parentheses 3 equals 5 parentheses 3. When you do this and hit enter, the calculator tells us that that is true. Here's our next example. We have 4c minus 7 equals 20 plus c. I have variables on both sides, and remember my advice is to move the smaller one. You can move 4c, but it's better if you move c to avoid negatives. The opposite of adding c is to subtract c on both sides. You can only subtract c from 4c because they have to be like terms. When you do this, c cancels on the right, and 4c minus c is 3c on the left. I'm going to bring down the minus 7 and the 20, and now I'm back to my two-step equation. My first step is to add 7, and then I'm going to divide the 3, so c equals 9. This example is combining our multi-steps to having variables on both sides. If you look carefully, we have parentheses, which means we have to start with distributive property. On the left, my like terms are combined. I can't do any simplifying there, so I'm going to leave that as 3 minus 4a. On the right, since I have a 5 outside the parentheses, I'm going to distribute 5 times a is 5a, and 5 times negative 3 is negative 15. Now I need to take care of my variables on both sides. I have negative 4a on the left, I have 5a on the right. I would personally move the negative 4a. So the opposite of subtracting 4a is to add 4a on both sides. When you do that, they cancel on the left, and you're left with 3. On the right, 5a plus 4a is 9a, and I bring down the minus 15. From here, I'm back to my two-step equation. So I'm going to add 15 on both sides, and then I'm going to divide by 9. Our final answer for this problem is 2. Go ahead and pause the video, try these two problems, and then restart when you're ready to check. For number 1, I would start by adding 8x to both sides. When you do that, you're left with 7 equals 12x minus 17. Your next step is to add the 17 to both sides. So 24 equals 12x. From here, I'm going to divide by 12, so your final answer should be 2. On number 2, I would start by moving the 3x over. Since 3x is positive, you have to subtract it on both sides. When you do that, you're left with 2x minus 2 equals negative 4. Don't forget to bring down that negative. From here, I'm going to add 2 on both sides, and then I'm going to divide by 2. X equals negative 1. Our next example is 1/2 parentheses x plus 2 equals 5x minus 8. My word of advice on this problem is to get rid of the 1/2 right at the beginning. So I would multiply by the reciprocal. In this case, the reciprocal is 2 over 1, which is the same thing as 2. What you have to be careful with on the right is you have to multiply every term by 2. On the left, since these are being multiplied together, you don't have to do the x and the 2 in the parentheses. You're just taking care of the 1/2 outside of the parentheses. So from here, 2 times 1/2 cancels, and I'm left with x plus 2. On the right, 2 times 5x is 10x, and 2 times -8 is -16. Now I'm back to variables on both sides. Since x is smaller and it's positive, I would start by subtracting the x. When you do that, you're left with 2 on the left, and 10x minus x is 9x. Bring down the minus 16. From here, I'm at my two-step equation, so I'm going to add 16 on both sides. And then I'm going to divide by 9. My final answer here is 2. Go ahead and try these 3 problems, and then we'll talk about them. On number 3, I would move 7w by subtracting it on both sides. From here, you're left with 1 equals w, or 1w, plus 1. Finally, you subtract the 1 on both sides, and we get w equals 0. On number 4, our first step is to distribute the 9. When you do that, the left side stays 9z plus 12, and on the right side, 9 times z is 9z, and 9 times 3 is 27. From here, I'm going to subtract 9z on both sides. If you notice, this is a special circumstance. This will not happen all the time, but it does happen. 9z minus 9z is going to cancel on both sides, and we're left with 12 equals 27. When this happens, when your variable cancels on both sides, you have to look and see if what you're left with is true or false. In this case, 12 does not equal 27. This is false. So our answer for this problem is no solution. There is not a number that exists that we can plug in for z that would make this equation true. This is a special case, so remember it only happens when your variable cancels on both sides. Number 5. You have to distribute on both sides on number 5. So, on the left, 3 times 2a is 6a. 3 times 2 is 6. On the right, 2 times 3a is 6a, and 2 times 3 is 6. To get rid of my variables on both sides, I'm going to subtract 6a. And again, my variable cancels on both sides. This time, I'm left with 6 equals 6. This is a true statement. So, if your variables cancel on both sides and what you're left with is true, we're going to call that all real numbers. You can plug in any number for a, and it will be true for this problem. So take a second to compare the 3 problems we just did. On the first one, we did have our numbers cancel. We did get 0, but w did not cancel. It's okay to have 0 as an answer. 0 is a valid answer. On our second one, our variables canceled on both sides, and what we were left with was false. That's how we put no solution. And then on our third one, our other special case, our variables canceled on both sides, but this time what we were left with was true. When that happens, we'll put all real numbers. Please make sure you study the difference between these 3 situations. That's what we just did. Oh, and we are done with solving multi-step equations and variables on both sides. Make sure you always check your answer either by plugging it in by hand or by using your calculator.